Okay. Way back in Cal 1, or maybe it was 2, you had a function and you looked at an integral as the area under the function. Do you remember doing that? And you had to take this area under here and divide it into rectangles. That was 2? Okay, Cal 2. And you know, the more little rectangles you got in there, the more accurate your integral was, and you did Riemann sum, and you did all that, and your teacher made you go through all that. All right, if you remember, you did left-hand endpoints on your rectangles, you did right-hand endpoints on your rectangles, and then you did midpoints. And that got you to the midpoint rule. All right, well, the midpoint rule we're using is the exact same rule you used in Cal 2. So, midpoint formula is this one. If you wanted to integrate, we're going back to it. I'm not going to make you do Riemann sums. I'm going to make you use the formula. If you're evaluating the integral from a to b of f of x dx using the midpoint rule, then you're multiplying delta x, which is b minus a over n, times your function evaluated at each midpoint. These x sub i's are your midpoints of each of your regions. It is exactly what you did in Cal 2. Exactly. You don't have to memorize these formulas, by the way. You probably didn't have to there either, did you? You probably just had to use them. Y'all had to memorize them? Oh, okay.
And I was told it's going to be there whenever you go to take the test and print it out.
Oh, okay. Okay. All right, this is the midpoint rule again. This is from Cal 2. It's the same rule. These x sub 1, x sub 2, the little midpoint of the little regions that you've divided your area into. All right, this is not the most accurate of methods because it involves a midpoint, and you do know that it involves an error, right? There's error. That white space is the amount of error that's involved in your integral. The white space here is the amount of error. Midpoint gave you less error than these two, but it still gave you some error. Okay. Another way to divide these instead of rectangles is to divide these regions into trapezoids. So if you take the area under the curve, and do trapezoids, then you can get even a little more accurate. And that leads you to the trapezoidal rule, which is this one. The integral from a to b of f of x dx with the trapezoidal rule is delta x over 2. And this time you evaluate your function at each of your endpoints. You multiply 2 times every term except the first and the last. So it's f of x sub 0 plus 2 f of x sub 1, 2 times f of x sub 2, 2 times f of x sub n minus 1 plus f of x sub n. Delta x is still b minus a over n. Okay. Midpoint rule is evaluated at midpoints. Trapezoidal rule is evaluated at each endpoint of your regions, of your little area. All right, last but not least, we have Simpsons rule, and it divides using parabolas. I know. When you use Simpsons rules, you have to be dividing your region into an even number of spaces. So n has got to be even. I'm going to work an example doing all this in just a second. And the formula for Simpsons rule, it involves parabolas, is delta x over 3, f of x sub 0 plus 4 times f of x sub 1 plus 2 times f of x sub 2 plus 4 times f of x sub 3 alternates 2 and 4 until you get all the way to the end where there's nothing. The coefficient is just a 1. Again, delta x is b minus a over n. N is an even number of regions. This is approximate integration. There is error involved in using every one of these methods. Pardon? That's why they're approximate, exactly. And this is used by the inside of your calculators when it can't give you an exact answer. When y'all get all of that written down, I will show you what we need to do for this problem. Still writing? Almost through. Okay. I am going to look at problem number 12 out of your book, where we are evaluating the integral from 1 to 3 of e to the 1 over x dx, and n is 8. So they want us to use approximate integration. They want us to do the midpoint rule, the trapezoidal rule, and Simpsons rule. They want us to do all three of them. So I'm going to go through and do all three of them for you. Alrighty. Now this just happens to be one of those integrals. If you stuck it in your calculator, it cannot give you an exact answer. Because I actually did stick it in my calculator to see if it would give me an exact answer, and it did not. So let me make sure, see where it is on here. At least I thought I did. Maybe it's on the other one. Okay, right here, if you can see it. I put in the integral from 1 to 3 e to the 1 over x dx, and it spit out the integral all over again. It means it could not give me an exact answer. So my calculator had to use an approximate method to get the answer. Okay, so here's what it had to do. This n equal 8 means that I have to take the region from 1 to 3 and divide it into 8 even pieces. So I actually draw out my picture. Visual. So 1, 2, 3. I need 8 even spaces between 1 and 3. There's half. I don't think y'all need to be clicking. Okay, 8 separate regions. I need each one of these endpoints because I'm going to have to evaluate these endpoints. I need to know what these are. How far apart are these? Well, I'm going to need delta x. Delta x, is b minus a over 8. So it's 3 minus 1 over 8. That's going to be 2 over 8, which is 1/4. So each one of these is 1/4. So this is 1 1/4. This is 1 1/2. This is 1 3/4. You can use fractions or decimals. It's not going to matter. This is 2. This is 2 1/4. This is 2 1/2. This is 2 3/4. And that's 3. All right, first thing they asked me to do is the trapezoid rule. So the trapezoid rule, pulling out my formula, I'm doing the trapezoid rule of 8. I need delta x, which is 1/4, divided by 2. That's the formula, delta x over 2, times f of my first endpoint, which is 1. So f of 1. By the way, what's my f? What's my f function here? E to the 1 over x. So my f of x is e to the 1 over x. This is your function. So f of 1 plus 2 times f of my next endpoint, which is 1 1/4, plus 2 times f of 1 1/2, plus 2 times f of 1 3/4, plus 2 times f of 2, plus 2, times f of 2 1/4, plus 2 times f of 2 1/2, 2 times f of 2 3/4, plus f of 3. The first one and the last one do not have 2 multiplied by them. Everything else has got 2 multiplied by it. Right. And when you finish, you better make sure you've got all the right terms. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. You should have 1, 2, 3, 4, 5, 6, 7, 8, 9 things in here that you've got to add together. So when I do f of 1, I've got to have e to the 1 over 1. When I do f of 1 1/4, I've got to put e to the 1 divided by 1 1/4. The calculator can make this very easy if you want to use your calculator. And I'm supposing you probably do want to use your calculator. I know I would. Do what? Right. And there's a lot of room for error. So what I did is I typed my function e to the 1 over x in here. And, and then I stored it and I labeled it f of x. So now all I have to do when I come down here, if I want to type in f of 1, it's going to put a 1 in there for me and give me an e. If f of 2 gave me the value of e to the 1 over e to the 1/2. So when you type all this in, you can type it in as, I'm trying to help you out here, this is 1/8. You can type it in as 1/8 times, open your parentheses and start typing in. You can just type in the way I did it. I type it in as f of 1. Then go out here and put plus. Then I can type in 2 times f of 1 1/4, which is what, 5/4? I'll probably type it in as 5/4. And you could keep going on like that until you get to the very end and hit enter, and it would give you an answer. Y'all just stare and ask me a question. The store button is right here if you want to. Yeah, blue and store.
Then you just went in after that one, I just got it all in my calculator. You just did like F1 plus.
F open, yeah, I label it f of x. F open parentheses x. You have to label it f of x.
Okay.
Right. So then when I put a 1 in there, it's going to evaluate my function f at 1 for me. And so I don't have to type in e every time. It saves me a little bit of steps. Go ahead.
Then you just keep adding like F1 plus F2 plus.
Right, you just keep going. This would be this one, then I'd have then plus 2 times f of 1 1/2 would be what, 3/2? Whoops, typed that in wrong. I do better with my other calculator. F of 3/2, and then you keep on going. And if this were the last of my problem, I would just hit enter. It gives me that, but I need an approximate answer. So to get an approximate answer, you use this little equal to right there. It gives you approximately 1.3, which is not the whole problem, it's just that part of it. Gives you the 1.38, blah, blah, blah. And that's how you can use your calculator to figure this out. Otherwise, you're going to have to figure out how to do it without rounding until you get to the very end of the problem. And I think they only want like 6 decimal places. So you would have to take this and don't round until you get to the very end, and then round 6 decimal places. All right, let's set up the others. If you need us to go back and practice the calculator, we will. All right, for part B, they want me to do the midpoint formula. Midpoint at 8. Well, unfortunately, to do the midpoint, I can't use these. These are endpoints. What I need to go back and do is get the middle of every one of these little sections for my midpoint. So those dots are the numbers that are going to go in my function f this time. So this one looks like this is going to be 1/8. So this is 1 and 1/8. This is 1 and 3/8. This would be 1 and 5/8. 1 and 7/8. That's 2. So then this would be 2 and 1/8. 2 and 3/8. 2 and 5/8. And then 2 and 7/8. These are for your midpoint. So for the midpoint, I need my delta x, which is still 1/4. And then I need f of my midpoints, 1 and 1/8. F of 1 and 3/8. Plus, keep going, f of 1 and 5/8. F of 1 and 7/8. F of 2 and 1/8. F of 2 and 3/8. F of 2 and 5/8. And then F of 2 and 7/8. And when you finish, you better have 8 things because you had 8 sections. So 1, 2, 3, 4, 5, 6, 7, 8. I've got 8. And that would be your midpoint rule. Again, it should be the same rule you use in Cal 2. These will give you different approximations because they involve a different amount of error. Take all these, add them together, and then divide by 4. And again, I would use my calculator for whatever your function is. Does everybody understand that each of these is evaluating your function at a point? Okay. Then part C would be Simpsons rule. Simpsons rule at 8. All right, well, Simpsons rule goes back and it does endpoints. So it's going to go back and do the same thing as the trapezoidal, except you have delta x divided by 3 this time. And these coefficients alternate between 4s and 2s. So it's f of 1, 4 times f of 1 and 1/4, 2 times f of 1 1/2, 4 times f of 1 3/4, 2 times f of 2, 4 times f of 2 1/4, 2 times f of 2 1/2, 4 times f of 2 3/4, plus f of 3. First and last are not multiplied by anything. The others alternate between 4s and 2s. Then you put that in your calculator and get another approximation. It'll be different than these two. They're all different. They don't vary by much sometimes. And that's all there is to it. And I don't mean really that that's all there is to it, but this can get very tedious. Very tedious. A lot of mistakes, exactly.